Good morning, Algebra 2 class, and welcome to another lesson. We're going to be doing 14.1 today. Got a question for you. Have you ever played Fruit Ninja, the app that was popular a few years ago? But I think that's going to be a good example to try and start you thinking about today's lesson. But in this game, Fruit Ninja, you have to slice through a piece of fruit and just think about the section that when you slice through it, the cross section that you would have of the image. We're not going to be cutting through fruit today, but we're going to be cutting through cones, trying to figure out what the different shapes are. So here we have two cones. We're calling them napes. And picture if you sliced through those napes. Like if you, for instance, if you slice through two napes on top of each other, two cones on top of each other, right there, what would, if you were to take those two cones and separate them, what would you have left? I believe you'd have a point. But then you could see that if you sliced through here, you would have a circle. Or if maybe you weren't slicing straight, you would have an ellipse and hyperbola and parabola. And we'll explain those. Here are some definitions to know, to be familiar with as you prepare for a test. A circle is the plane perpendicular to the axis of a cone, and the ellipse and the parabola, and those are just the definitions. You should be familiar with them, kind of think about them. Also, a cone can form two intersecting lines, two lines that cross through each other that would meet at the points of both cones. Okay, so again, here are some examples of those cross sections. We're going to talk about each one on a Cartesian plane in detail, so that there's going to be a number of lessons in this chapter, and each one of those will describe another one of these conic sections. So, okay, yeah, again, we got the circle, the parabola, the ellipse, the hyperbola, the line, and the point. Those are the conic sections. So the first one that we want to focus on today is the circle. The circle is the locus of points to a fixed distance from a point. That's kind of the compass rule. If we wanted to make a perfect circle, what we do is we would take a stake and put it in the ground, and then we'd come up with a string or a chain or something and attach it to that stake and use that as our radius and use that as a guide to determine the circle. Now, here this is in the best graphing equation that we can have for graphing a circle. And it has to be this format. X minus h squared plus y minus k all squared equals r squared. We are going to look at times where we don't have it in graphing form. You know, we've already done a lot of work on parabolas and quadratic equations this year, so we're kind of familiar with that, taking something from a general form and putting it into our graphing form. HK, as we've already talked about this year, is the center of the circle. When we were looking at the parabola, that was the vertex of the parabola, but in this case it's going to be the center of our circle. And we note that in both h and k, they are labeled as negative. So that means that the actual coordinates of the circle will be the opposite. And I always say that if there's a negative in your graphing equation, that means that it's lying to you. And in this case, H and K, they do lie to you, and they always have to be opposites. Earlier in the year, I explained to you why that happens, so just kind of remember that rule. And R stands for the radius. So let's begin looking at the circle today. This is a very, very simple circle. And everything's there that we need, and it's already in graphing form. This should be a simple circle to graph. The first thing that I want to note is the center of this circle. So we're going to look for the HK value, and we're going to remember that both H and K lie. So if up here I've got a -3 and a +2, My HK value is going to be positive 3 because they lie, and negative 2. So if I'm also responsible to graph this equation, I'm going to put the center there at positive 3, negative 2. With me so far? I hope so. The next thing I want to look for is the radius. Well, according to the equation that I had on the last page, r squared is equal to 9. Because if you look back, and I'm going to go back, it always equals r squared. That's very, very important. That's one of the things that can trip you up in this lesson. This value here is not the radius. The radius is not 9. The radius squared is 9. But in this case, it's kind of easy for us. It helps us out a lot because that makes the radius positive or negative 3. So that means that if I were to go to the center right here again, and I were to go up 3, I'd have a point on the circle. And if I were to go right 3, I'd have a point on the circle. Down 3, I'd have a point on the circle. And to the left 3. So each one of those has a radius of 3 units. Now, it would be hard for me to go 3 units at a 45-degree angle and then a 30-degree angle and do it over and over and over again. I don't need you to do more than those 4 kind of corner points of the circle. And then you can do your best. Again, I'm not the greatest artist, so mine might look kind of funny to draw a circle. But as long as you have kind of those 4, I know they're not corners like you would have in a square, but those 4 endpoints that are very consistent, and then you do your best to draw a circle, I'm okay with that. Okay, again, that's pretty simple. Nothing too complicated there. Just as long as you remember the HK rule and the radius, you should be fine. So let's look at another one. This one I chose because it deals with what do you do when there's no H, there's no K. Well, I like to even rewrite these equations to kind of help us. Isn't this the same as saying x plus 0 squared? Plus y minus 1 squared equals 16. Sometimes that'll stump students, so I kind of wanted to handle that as we were getting a little further into this. So what would the center be? What is HK? What do you think H would be? Hopefully you said 0. And our K value, remember, K lies. So if K is negative 1 in the equation, our center is at 0, 1. So if we were to put that on the graph, our center is at 0, 1. Now we're going to look at our radius. Well, r squared is 16. Remember, it equals r squared. 16 is not the radius. That's r squared. The radius is equal to positive or negative 4, which happens to fit on my graph a little bit better. So from that center point, I'm going to go up 4, to the right 4, down 4. Be careful there. Don't the center is not always going to be at 0, 0. Some people just automatically put that at negative 4, and then their circle looks a little bit oblong, and negative 4 over from the center. Those are all distances from the center. Now, again, I just have to do my best at sketching a circle, and you can see especially that last line was kind of terrible. I'm not an artist. I don't grade you on your artwork. You don't grade me on my artwork. All right. Hopefully you're following along and you're doing pretty good. If not, make sure you give me some questions or ask me questions. You can email them, give me a call, and I'll be happy to help you. All right, as we move on, we can see that this one brings up a new problem. The problem here is that this particular equation is not in graphing form. Let me remind you what graphing form looks like. It's x minus h squared plus y minus k all squared equals r squared. So as you can see in this particular problem, we're not in the right form because there's multiple x's here, and they're not in parentheses, not squared. These have these don't have that perfect square that we need in order to be able to graph it. So we're going to take the time to put that into that form. So the first thing I'm going to do is I'm going to put these in parentheses. X squared plus 2x. I'm going to put a line there. Plus y squared minus 6y. If I put a line there, equals 7. Maybe you're beginning to follow what I'm going to be doing. But we're going to be doing a process called completing the square. We've worked on that a lot this year, and it shouldn't be something new to you, but it's going to be something that's going to really help us get through this. So I'm going to kind of go step by step, at least on this first one. With completing the square, if you'll remember, we take our b over 2 value and we square it. So b in this case is 2. We're going to divide that by 2, which is 1. And we're going to star the 1, and we're going to square it to get 1. And what I'm going to do is I'm going to add that 1 right there. But whatever I do to the one side, I have to do the other. So that means if I add 1 in there, I also have to add 1 on the opposite side. I'm going to do the same thing with my y value. Get a new color here. Let's go with green. Again, I'm going to take b divided by 2, and I'm going to square it. b is negative 6. I'm going to divide that by 2. I'm going to square it. Negative 6 divided by 2 is negative 3. I always love these when they're odd numbers. I'm going to star it, and then I'm going to square it to get 9. And if I add 9 in there, I have to add 9 to the other side also. That's going to get me a lot closer to what I'm looking for. And what I'm going to do now is I'm going to perform a CTS, or completing the square, completing the perfect square. This is a perfect square trinomial. That means that there's two binomials that are going to be multiplied together in order to get that trinomial. Well, what that comes down to, and again, we've done this the long process before many times this year, is that this becomes x plus 1 squared. You might say, why, Mr. Wilson? Well, there's two reasons. One is I start it right there, and I always star that value so that I can bring it into my completed square. But think about what x plus 1 times x plus 1 is. If I were to FOIL that out, I get x squared plus 1x plus 1x plus 1, or x squared plus 2x plus 1. Now, if we're paying attention, x squared plus 2x plus 1 is what I already had up there. So the factored version would be x plus 1 times x plus 1, which is exactly x plus 1 squared. I can do the same process with y. With y, it's going to be y minus 3. Do you know why I used negative 3 there? I hope you said it because it's what I starred right over there. And then it equals the sum total of these values right here. 9 plus 1 plus 7 is 17. Now you can see I can have it in my graphing form, which is right up here. I did that by a process called CTS, completing the square. That allows me to find my center. My center in this case, the HK value, is found at negative 1, positive 3. And my radius squared is at 17. I know that's not a nice value. I was just thinking to myself it would have been so much better if at the beginning of the equation I had started with a 6, but this is okay. My radius is the square root of 17. And you might go, okay, Mr. Wilson, so what does that mean? Well, think about it, estimate it. I'm going to put down an approximation, but just think about it in your head first. before you start trying to solve this problem or getting your calculator, what would it be approximately? Well, I think approximately you could see it's just going to be a little bit above 4. As a matter of fact, got my calculator out, and the radius is approximately 4.123. I just love that 1, 2, 3. But anyways, when it's time to graph it, we're going to go first to our center, which we decided was at -1, 3. And then my radius is about 4.1, so I'm just going to go a little bit past 4, a little bit past 4, and a little bit past 4 units, and a little bit past 4 units. I'm going to kind of estimate 1/10 past 4. And then I'm just going to sketch my circle as best I can. And I have a circle of that equation. Let's do this one more time. This time we're going to try to do this a little bit quicker. All right. This time, what I want to do is I want to complete the square by doing b over 2 squared, which is 4. I'm going to star it and square it to get 16. Whatever I do to the one side, I'm going to do the other. So I'm going to add 16 here. Then I'm going to take my other value, which is -22. I'm going to divide it by 2, star it, and square it, which gives me -11. I'm going to star it, and I'm going to square it to get 121. So that means I'm going to add 121 over here. Okay, so now I can put it into graphing form. So I'm going to have x plus what I starred, which is 4, plus y, and what I starred, which was -11. The negative is important, equals 56, no, -56, plus 16, plus 121. I got 81. So that means the center is going to be -4, 11, because remember h and k lie. Radius squared equals 81, and the radius equals 9. I hope you can kind of see that this is not going to fit on my graph, but I hope that you get that this would be in the center would be quite a bit up in my second quadrant. That means someplace up here, and my radius would be quite large, something like this. And so my circle would look very similar to that when I got done graphing. Okay? All right, let's move forward. My next problem. This particular problem, I am not necessarily given the equation, but I'm giving some pieces of the equation. C is going to stand for the center, and R is going to stand for the radius. So we're going to kind of work backwards in this particular problem. If R equals the square root of 5, what does R squared equal? Well, we square that value, and we're going to get 5 for R squared. The center, we know, is at 2, 0. So when I'm going to write the equation, I'm going to put in that h and k lie. So it'd be x minus 2 all squared plus y plus 0. You don't really have to add in the 0. You can just put y squared equals, now remember, it's not r, it's r squared. So that would be 5. And this is kind of a simple one to graph, because it already tells us that the center is 2, 0. The square root of 5 is where we're going to have our radius. So we can find an approximation of that. And the approximate value of the square root of 5 is 2.23. So about 2 1/4. So from there, I'm going to go 2 1/4 over, 2 1/4 down, 2 1/4 to the left, and 2 1/4 up. I'll connect my dots to try and make them look circular, and I should have a circle. That wasn't too bad, was it? Here we have another equation. And in this one, this one's not going to be, I'm going to cover this in the lesson, but this is not going to be a question on your homework. I have already chosen what homework questions we're going to do. So this one will help you understand the concept, but don't get too excited. This isn't going to be something that's going to be on your homework. It says someplace on the circle is the point 0, 0, and the center is 6, negative 4. We're not told the radius. We got to find the radius out. So we go 6 over and negative 4 down. So this is the center, and this is some point on our circle. So if we want to find the radius, couldn't we sketch the radius? Wouldn't the radius look like that right there? This is the radius. So there's a couple of methods that you could use to find the radius. One of them being you could use the distance equation. I always think to myself, memorizing formulas is a bad idea. I do know that formula, but I'd like to be able to problem solve this even if I didn't know the formula. So what I could do is I could sketch my own right triangle. And I know you're saying, Mr. Wilson, you have to know Pythagorean's theorem in order to be able to solve this. And that's a formula, but everybody knows Pythagorean's theorem. A squared plus b squared equals c squared. This is 4, and this is 6. That's the distance is, and because it's on a Cartesian plane, it's kind of easy to count. 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6. It's pretty simple to come up with those values, and so we know a squared plus b squared equals c squared. So we got 4 squared plus 6 squared is going to equal my radius squared. So 4 squared is 16, and 6 squared is 36. Add them together, and we're going to get 52 equals r squared. And you guys can remember, sometimes we want to simplify these. This is going to help you as you work through your book. This is 2 root 13. So we could say that r squared equals 2 root 13. Oh, sorry, excuse me. R equals 2 root 13. And r squared equals 52. Okay? So if we were to graph this, we just kind of keep a square root of 52 is approximately 7.2. So r is approximately 7.2. So we can go up 7 units and a little bit more, over 7 units and a little bit more, and our circle would look something like that. And the equation that we'd have would be, and that's what I'm really concerned with, x minus 6 squared, because of my center, and y plus 4 squared, remember h and k lie, and r squared equals 52. All right. Thank you guys for coming and getting my lesson. This is 14 questions, which is what I originally had for you. I just decided I was going to cross off the last 4, and I'll give you 10 questions. They're all covered in this lesson. A lot of them are pretty simple. I hope you guys have a great day. Thank you for listening.